There was an aquifer study done. It started about 20 years ago. It was a partnership with DGS, so Pete McLaughlin, he is one of the senior scientists in our group, and he's actually recently became director of the survey. This project was in partnership with the Delaware Department of Natural Resources and Environmental Control, or as we call them, DENREC, the water supply section. So the study mapped the depth and thickness of 12 confined aquifers in Kent and Sussex counties. There was hundreds, and I might dare say thousands, of borehole data points that were used in the study, lots of QA, QC. So in those boreholes, they wanted to identify where the tops and the bottoms of these aquifers were. Locating the aquifers is very significant information for well permitting for the water supply section and for lots of hydrologic studies. Lower Delaware is mostly agricultural, although when I drive around and I see all of the development that's happening, it's kind of scaring me that we're kind of losing that to development. But a lot of agriculture. Actually, also we have a lot of chicken plants too. So there is a lot of that kind of waste that we have to deal with that's going into the surface water. Groundwater in general, there's more demands, just like everywhere else. We have a lot of population growth, especially in the coastal areas. So the work, like I said, started about 20 years ago. It completed in about 2015. So all of the data was packaged up and a contract report was written up and delivered to DENREC. And DENREC used this data for all of these years, like I said, for all of their permitting. Eventually, this contract report did finally become a publication, a Delaware Geological Survey. Our data and research we disseminate to the public through our publication series. So bulletin number 22 was released finally in 2023. So this is just an example of the many beautiful figures that Pete had in his report. So for each aquifer, there was a figure to identify where the top, the base, and the thickness, overall thickness of each aquifer was. So take 3 times 12. I guess technically there was 13, but there's this unconfined aquifer that we don't talk about. It's kind of the enigma. And also there's subcrop zones where some of the aquifers touch each other, and there's all that technical information. But basically, you know, I helped with these figures, and when I look at these, and this is me not technical, not being a hydrologist or a geologist, you know, I can look at it and I can see the top of the Mount Laurel to the north looks fairly shallow, but as you go further south, it dips rather deeply. And I'm like, okay, I get the general trend of what I'm seeing, but then I have to think about this, you know, 12 times. You know, and I was like, well, I don't know that I can necessarily visualize this. So then I'm thinking, you know, 2D's all right, but, you know, why can't we make this 3D? So I had gone to Pete and I just said, hey, wouldn't it be really cool if we could see all of this stuff in 3D and, you know, kind of really get a better understanding of it? So on my own, I decided to take the data of his, and I generated 3D polygons for each of the aquifers. And back then I was still using ArcMap, so anybody here that's used ArcMap or maybe still using it, the only way you could render 3D was you had to open ArcScene. So in ArcScene, I was able to take those 3D data layers, and I exported them as 3D web scene files, and then I just uploaded them to ArcGIS Online, and I thought, well, let me see what happens. You know, can I render this online in a map? And sure enough, I did. I guess I went to open the file, and instead of opening an ArcGIS Online map, it was a City Engine that automatically in the browser tab came and opened it up, and it was pretty cool. But I wasn't able to release it to the public because the publication wasn't officially out yet. So I kind of put that on the back burner and waited. Over time, and I'd say it happened about 2 to 3 years ago, I went to look at it one day and it was just gone. It just wasn't there in my account. And I think what happened was, and what I'd been hearing about, is one of the ArcGIS Online updates basically just did not recognize that file format anymore for me. And I was like, well, okay, now the publication's ready to come out, and now I have to start all over again. So I was like, well, ArcGIS Pro, you know, has got 3D capability, so let me go from there. So from here, I'm just going to step through the steps that I had to go through, which sounds pretty easy, but in the end, it was actually very difficult to figure out overall how to get from the point A to point B. The very first part was the same. So pretty much what I had to do was take the raster layers, and I had to make those into 3D. So I used a tool called Extrude Between. So what I basically did was took each raster, converted it to a tins, because then with the Extrude Between, they needed tins, so that I could output a multi-patch feature class file for each of those aquifers. So I had, the 12 multi-patch feature class layers, which basically gives that feature class layer the Z value, or that 3D information that I needed. So in Pro, I just, opened those layers up in the new local scene, and I was able to add those files to Pro. And in Pro, I wanted to be able to set the colors for each aquifer, because in our publication series, all of our surficial units, aquifer units, all of them have a specific CMYK color. So at least for I guess DGS, and I guess any geologists or hydrologists are familiar, like yellows are typically from the Quaternary period and that kind of thing. So I wanted to be able to set those same colors so that it was recognizable to the scientists. Also, looking at it without any vertical exaggeration, just like with Delaware, it was not very exciting to look at. So I had to do some vertical exaggeration. I played around and finally played around, and the magic number was 15. I wanted enough elevation or exaggeration, but not too much. So I was able to set that for each aquifer. And then in Pro, there I had my 3D units again. Just a quick snapshot on the left of what it looked like. And the one on the right, I just wanted to show you the little weird artifact that happened. I guess those aquifers were shallow enough that by the time I did the exaggeration, they popped up above the elevation, above the surface of the map. I wasn't concerned about it at the time. I was just happy to get 3D. But in the review process, there were some people that had concerns about that. But I do address that later. I just wanted to show that to you now. So then at that point, I had it in Pro, and I was like, okay, now I need to get it back out into ArcGIS Online. I had tried that other file format. The problem was I wasn't able to bring the vertical exaggeration out with it. And I was like, okay, without that, I might as well not even publish it. So I tried other file formats. It wasn't working. Basically, I ended up asking somebody at Esri for help. I don't know if anybody knows the name Nathan Shepard. He's the 3D guru over there. I was like, if anybody's going to know how to help me, it's him. I'm just going to email him and ask. And he answered me. And he helped me through, and he even took my data and played around with it and everything. And he was a really big help. So pretty much what I needed to do was to create scene layer package files. So it was this tool in the toolbox, create 3D object scene layer content, very long name. But all I had to do was just take those multi-patch feature class files and convert them to these scene layer package files. So I had 12 of those, and then I uploaded those to ArcGIS Online. The next step was I wasn't sure. I just went to open it, and it wasn't automatically, bringing up Cindy Engine or anything, so I wasn't sure what to do. He said to use ArcGIS Scene Viewer. So then that was a whole separate tab that I had to open, added my layers in there in a local scene. That's an important, I'll talk about that in a second. The other thing I didn't realize is that, so we, by default, whenever we open an ArcGIS Online map, we see that Esri basic topo map that they have. Well, in Scene Viewer, they have a 3D version of it. So it's really cool. When you turn it on its side, the text actually stands up like a billboard. So you can get a sense of location when you're turning it sideways. So I thought that was really awesome. The other tip that he gave me was to make the base map zoom to the local area, or what he called a fish tank. And I was like, what do you mean by that? So he said, especially since Delaware is so small, basically cut that map to my area. So what I needed to do was just zoom to portrait style, since Delaware is, portrait. Kind of zoom to the area I want of the map to cut out. And then he said, there's a toggle button that says clip to extent. Just click the toggle button. And I looked and I looked, and I was like, where is this toggle button? I don't see it. And he said, oh, you opened a global scene, not a local scene. That's why it's not even there. And I was like, oh, in my excitement, I didn't realize what I had opened. So I had to go back, do the local scene, then it was there, then I could then I could clip it. I was like, yay, but then it wasn't exactly where I wanted. So pretty much you have this update to current view. You keep re-zooming until you get exactly where you want and click the update until you finally get the area you want. And then I got my fish tank. So then the other thing that happened was when I brought those layers and opened them up in there, I had those little artifacts that were sticking up above ground. In Pro, I was able to take everything and I brought it down about, I played around with the numbers, and 700 feet was taking the last unit below ground. But unfortunately, when I exported them to the scene layer package, it didn't hold. So then I was like trying to figure out how to do it in Scene Viewer, and it was very difficult to find, but I finally found it. It was a lot of clicking around, but pretty much in the layer properties for each aquifer, I had to go select Configure More, and then I found where I could do the offset. So then I was able to do that 12 times to bring all of my aquifers back below ground, and then all my reviewers were happy. So then I had a really cool map, and just like with an ArcGIS Online map, you're like, okay, I could just distribute that to everybody, but it would be better in an app. So at this point, since Instant Apps had just come out, they had a 3D viewer, so I went ahead and plugged that map into the 3D viewer. Now, when I did it a few years ago, back when it first came out, there really wasn't a whole lot of widgets and options, and I was like, well, okay, it's in a viewer, and it's got some widgets in there, it's okay. But when I redid it within this past year, they did add a lot more in there now. So pretty much you just go through the steps, selecting a header and the color and if you want a cover page or not, etc. So just go through all of those steps, which I won't go through, just basically to set it up in the 3D viewer. So just to show you the app, Pete wanted a cover page just to generally explain about the app and the publication it comes from, and then like a little disclaimer page. Mostly at the bottom, he wanted to explain. In some areas, if you look very closely, there's some of the aquifers that are actually kind of crashing into each other when they're not supposed to. And basically, there's not enough data points in that area to resolve that. So that was just a disclaimer to explain that error for the scientists that notice these things. And also the fact that the data was taken and exaggerated 15 times. And then, like I said, it's just got the app and turning it sideways, and I can see my text still. I thought that was really awesome to be able to do that. And see if I can, I'm not used to using this kind of mouse, but the trackpad would have been a lot worse, so forgive me. And then on top of that, I'm using it on a piece of wood here. But I really like to look at this from the west side, because for me, as not a scientist, I really got to appreciate especially those lower two aquifers, which are the Rancocas and the Mount Laurel. Yeah, so Mount Laurel's the deepest one, and then the Rancocas. But just pretty much in the 2D, you could see how shallow they were up north, but then as you go south, I mean, really how much further down they dip, lower than the other aquifers. But like I said, looking at it in those 2D figures, I would have never really been able to see this type of thing. So I just thought, for non-technical people, it really gives them a better idea of pretty much, where is your groundwater coming from, and just seeing, all of the different aquifers. It's not just one, because I just think, oh, you just go underground and you hit water and that's it, It's actually much more complicated than that. And there are lots of widget options, but the only one I decided to include was this slice tool, which I thought was pretty neat. So let me do that. So then you can cut through a cross section there. And I think this is how one of our scientists quickly saw those areas of error, and Pete didn't even realize they were there until, I think he did, but he didn't. And then he was like, oh yeah, that. So that can't be helped. But yeah, I just thought this was really fun to do. So, and let me see, I've got my 5 minutes. I think I'm okay. That's it, I'm good. So that's it. Just a QR code for the app. I did check it, it should be working. Because originally when I first did it, luckily I checked it and I actually had the link to the story map presentation, which wouldn't have been terrible. But Yeah, it's public, it's on our website, on the Web Maps tab. Our website is actually going to be revamped pretty soon, and also the Delaware First map. It's our Delaware's enterprise GIS. There's links to that and some other apps we have as well. So, yeah.
And we have time for a question or two.
I might have missed it because I had to go put my map away. But when you got how did you get the like? Did you just have like data on like where they like start and stop like elevation wise?
Yes. So Pete had generated raster layers. So each raster defined the top and the bottom of each aquifer, and he had used borehole data to create the raster file.
Super cool. Thank you.
Yeah, and then the raster was converted to tin, and everybody's like, well, why didn't you just start with a tin? But I think with as many data points as it seemed like it wasn't enough data to really, the tin would have not looked as smooth. So starting with the raster and then going to a tin was actually a better process with the data he had.
We have time for one more question, if there's any. Okay, thank you, Lillian.
Thanks.